Hello, today we are going to look at the 6-4 worksheet, proving a quadrilateral is a parallelogram. So this one and the next section have sort of lots of things in common, just proving different ideas about parallelograms and their sides, their angles, and how they relate to one another. So number 10, if you are given a drawing of a quadrilateral, how can you determine whether or not it is a parallelogram? What tool or tools can you use? So of course you can do this a few different ways. If you've got tools, you can measure the opposite sides with a ruler to see if they're congruent. That's what I'm going to write down. Measure the opposite sides with a ruler to see if they are congruent. You could also measure the angles with a protractor to see if the opposite angles are congruent or if the adjacent angles are supplementary. Ahmed uses the following explanation to prove that the figure is a parallelogram. What is Ahmed's error? So he says the quadrilateral has a pair of opposite sides congruent and a pair of opposite sides parallel. According to this theorem, which is that one pair of sides is both parallel and congruent, the figure is a parallelogram. But in order to use that theorem, the parallel and congruent theorem, the same pair of sides has to be both parallel and congruent, not a different pair of sides. So that's what we need to write, is that the same pair of sides, the same pair of sides needs to be congruent and parallel. Needs to be congruent and parallel to prove a parallelogram. The way that this one is written, it could be an isosceles trapezoid with one pair of parallel sides and the other sides are congruent. That is the main points of an isosceles trapezoid. All right, coming down here. So it's write a proof of theorem 6-12, and you might say, well, what is that theorem? They give you the idea. If we know that the angles next to each other are supplementary, we want to show how proving that the angles next to each other are supplementary. Why is this quadrilateral a parallelogram? So if F and G are supplementary, that means that FJ and GH have to be parallel because the same side interior angles are congruent. If F and J are supplementary, that means that FG and JH have to be parallel because their same side interior angles are supplementary. So we can say by same side interior angles, we know FG is parallel to JH and FJ is parallel to GH. So FGHJ is a parallelogram by the definition of a parallelogram, two pairs of parallel sides. So by definition. There you go. Number 17, in each figure, what values of x and y is the figure a parallelogram? Just lots of solving here. So we've got 3x plus 6 equals 4 minus x. Solve that equation. Let's divide by 4. X equals negative 0.5. Let's see, I am doing this online, so I shouldn't have any scribbles. There we go. And then the other one, we've got y plus 2 equals 2y minus 3, and we'll solve that one. So y is equal to 5. So x equals negative 0.5 and y equals 5. For b, same thing, but this time the opposite angles is what we're going to be looking at. So 4x minus 12 equals 3x plus 5. So x equals 17, and 3y plus 46 equals 5y minus 6. So 26 is equal to y. Number 18, given the lengths shown for what values of w and z is the figure of parallelogram. Again, same idea. Our diagonals of a parallelogram bisect one another. So 3z minus 2 equals 2z plus 3. Z equals 5. And then 4w equals 20 minus w. So we'll add w to both sides. And w equals 4. Moving on, writing another proof. A proof of theorem 6-15, which is the one that tells us if we have one pair of sides that is both parallel and congruent, then the shape is a parallelogram. So here's one way to do it. They give you a hint. It says construct diagonal JL. And so I am going to do that. And once I do that, I can start my proof. I can say, all right, well, I know that KL is congruent to JM, because that's given. I'm writing a paragraph proof, by the way. And I also know that these pairs of sides are parallel to one another. So I should write that in as well. So KL is parallel to JM, that's given. And since those two lines are parallel, I know that angle KJL is congruent to angle MJL, right? Not KJL, it's KLJ. That's why. KLJ is congruent to MJL by alternate interior angles. I knew that those were going to be congruent. Okay? And I know, what else do I know? I know that by the reflexive property, JL is congruent to itself. Congruent to JL by the reflexive property, which means that triangle KLJ is congruent to triangle MJL by side angle side. Since those triangles are congruent, I know that KJ is congruent. Well, I'm actually not going to do KJ and LM. I'm actually going to use angle LJK. Angle LJK is congruent to angle, let's put two arcs there, is congruent to angle JLM. And I know that because of CPCTC, so those angles must be congruent. by CPCTC. Since those angles are congruent, I can consider them to be alternate interior angles on LM and KJ. So I can say by alternate interior angles, KJ is not congruent, whoops. KJ is parallel, because that's what I need to show that there's a parallelogram here. KJ is parallel to LM. So now I've shown that there are two pairs of parallel sides. Then I can say, since JKLM has two pairs of parallel sides, it is a parallelogram. A parallelogram. There we go. Number 22, Simon wants to decorate a cake with a pattern of parallelograms. We don't know why, but all right, go off, Simon. He first pipes two parallel lines that are 3 inches apart. He then makes a mark every ½ inch along each line. He pipes the line from one mark to the next on the opposite side. Does this ensure that the lines will be parallel? Explain your answers. Well, if we look at each of these parallelograms in turn, we can see that one pair of the sides is parallel. He piped those two sides parallel. Let me get a better color here. He piped these two sides parallel. And since he made the marks every ½ inch, those two sides are also congruent. So, yes, we can say yes, they're parallelograms. So yes, because one pair of the sides on each quadrilateral are both congruent and parallel. Because one pair of sides on each quadrilateral are both congruent and parallel, making them parallelograms. There we go. And last couple here. We don't need to copy the graph, but we can plot all possible coordinate pairs for Q on the coordinate plane so that P, Q, R, and S form the vertices of a parallelogram. All right, there's going to be 3 of these depending on which way we see this parallelogram going. And I'll kind of fill in the side lengths I'm talking about. So if here is 2 sides of our parallelogram, then the 4th side is going to have to be parallel, and it's going to be out here somewhere. It's going to be parallel to this line. So this line we went, let's see, -2 to 3. We went over 5 and up 5. So then from this line, I'm going to go down 5 and over 5, and I'm going to put a point at -4, -8, which is kind of off the graph, but that's okay. So -4 and -8 would make one of our parallelograms. But what if I thought my lines went together this way instead? If my lines went together this way, then my 4th point would be up above, and it would be parallel. So let's see, from point S to point P, I go over 3 and up 2. So if I go over 3 and up 2, my next point for this parallelogram would be on 0, 6. And finally, if I thought that my lines connected this way, then I would get another parallelogram. Let's see, this went down 3 and over 2. No, sorry, down 2 and over 3, I can count. So down 2 and over 3 from R puts a point at 6, 2. So those are the 3 points that I could have that would make these 3 given points into a parallelogram. And then 25, in quadrilateral ABCD, angle A is congruent to angle C. Which additional statement can be used to show that ABC is a parallelogram? Let me draw a quick one here. We've got A, B, C, D, so we know the opposite pair of angles is congruent. If I know one pair of angles is congruent and that same pair of angles is supplementary, that's not going to help me. If I know that, well, actually, if the same pair of angles is congruent and supplementary, it makes them 90 degrees, and it shows that this is a rectangle. But it just needs to be a parallelogram. If I know that BD bisects AC, then that's nice, but that's not using the given information here. If I know that the measure of angle B plus the measure of angle D is 180, those opposite angles being supplementary doesn't actually mean anything to me right now. But if I know that angle B is congruent to angle D, I know that the opposite angles of my shape are congruent, which means I have a parallelogram. All right, if you've got any questions on this, make sure you ask me in class. Other than that, have a